Good morning, everyone. And in this lecture, I'm going to tell you about finite state machine with output, or in some literature, it is also termed as finite state machine as transducer. Why it is called so? Because here in this kind of finite state machine, we are not checking the validity of any string, or we are not it is not working as language acceptor. It is actually taking some input string and giving you some output string at the output side. That means it is calculating something for you, or it is computing something for you. For example, if you take an instance that where you have to calculate or you have to count the number of ones and number of zeros in a given strings of 0 and 1, then on input side you have given a random binary strings of zeros, let's say 001, and on output side if it gives 2 1, that means there are two zeros in your input strings and one in your output string. So this is how this finite state machine is with output is going to work. And under this classification, we are going to study two machines: finite Mealy machine and Moore machine. So, and the main application of these machines are in digital circuit design. So as you can see here, I've for your understanding, I have written here that on input string, you are giving some set of input string in the input side, and you are when you are getting a particular output string as per your requirement, then it is called as a finite state machine with output. Okay. On the contrary, what was happening in finite state machine without output, that in that kind of machine you were giving some string and input, and on output side you was getting valid and invalid signal, or 0 or 1 signal. That means binary output you was getting. In that kind of machine you were testing the validity of string, but here you are generating a new output for a given string. So there are two machines, Moore machine and Mealy machine. So I'll discuss it one by one. First of all, Moore machine. So a Moore machine can be defined here with the help of 6 tuples: Q, sigma, del, delta, lambda, and Q naught. Now, few of the tuples are known to you very well, because you have already seen these some of these tuples in earlier machines, and some of the tuples here are new to you. So I will explain it one by one. So Q, capital Q, is again came here, which means the finite set of states. The meaning is same as it was in there in finite state machine without output. Sigma is again the set of input alphabets. Whatever input alphabet you are giving on the input side, whatever input strings constitutes of, will come under this set, and that is set of input alphabet, and it will be termed as sigma. Okay. Del is the transition function, and again transition function here is also the same. It is a function that tells us the pattern of movement from in any machine from one state to another. And here in case of Moore machine, the transition function is same as DFA, that is Q cross sigma maps to capital Q. That is the transition function of deterministic finite automata. There is no case of non-determinism will exist here. Okay, so on reading some input symbol from any state, we will reach to a particular definite state only. Next tuple is delta. We will term this triangle symbol as delta here. And now this delta is symbolizes here as set of output alphabet. Whatever output string you are getting, the alphabet used in that output string will constitute this set, and that will be called as delta, set of output alphabet. Next tuple, which is new to you, that is lambda. This lambda is called as output function. This is the important part of this machine. This is the different thing which you have came across, which is different from previous machines. Output function. Now, what is output function? It is a function that tells us on in what pattern this machine is giving output to us. So here I have written its output function as q maps to delta. That means here output alphabet is associated with states. That means whatever the state is, according to that state, the output alphabet will be decided. So yeah, here I have written it in words also. Output alphabet is associated with states. So whenever Moore machine comes in your mind, you have to remember this line that output alphabet is associated with states. Okay. So that is why I have written here as Q maps to delta. That means delta, that is output alphabet, is associated with state. And lastly, Q naught is the initial state, as it was in the finite state machines we have studied earlier in earlier lectures. And it is the one of the states which has been picked up from this state Q. One more difference you can observe here is that is this machine does not consist of a set of final state. Why so? Because we do not have to check the validity of any string. We do not have to accept or reject some string here. So there is no rule of final state here. We have to compute some function, or we have to calculate some output for some string. So there is no need of a final state here. So that is why f is omitted out from here. So these 6 tuple will constitute a Moore machine for us. For an example, by taking an example, I will show you how to draw a Moore machine and how to draw its transition table. So this is an example of Moore machine. In some book, you can find it like this, that it is written as name of state is written here, and its output alphabet is written here with a comma. So both these things are same. Either you can write it with the help of comma, or you can write it with the help of a slash symbol. So both the things are same. Here you can see that an output alphabet, as you can see, small p is associated with state A here, and small q is associated with state B here. Okay. So the transition, on making 0 transition from A, we reach to state A only, and we are giving output as small. And from state A to by reaching to state B, we are giving output Q. So let us take an example and see how this machine is giving some output string at output side when you give some input string to it. So let us take an example. Suppose you have given this string at input side to this Moore machine. What will happen? So at first, our control will be at initial state, that is A. On reading first 0, what will happen? We will reach to state A again and will produce an output small p, because on reaching to A, you are immediately generating an output small p. So at output side, you will get p here. Again, on reading 0, we will again make the same transition and will again make an output small p. From A, on reading 1, we will reach to state B and will give output Q, because B with B state B, Q output is associated. Now I am on state B and I will read next input alphabet, that is 0. So on reading 0, I will reach to B and I will give an output Q. Now the last input alphabet is 1. So from B, when we'll read 1, we'll reach to state A and will give output P. So now this string has been finished. So with respect to this input string 0, 0, 1, 0, 1, you can see we have given an output of P, P, Q, Q, P. Okay. For this instance, it is not making any relevance, but you can construct any Moore machine which can serve your purpose as per your problem. So I'm just telling you that how this Moore machine is giving some output string at output side. Okay, and now this is the transition table for it, where this portion of transition table is known to you because you have learned it earlier also in previous classes, that on giving a 0 to a, you are getting capital A. On giving 1 to state A, you are getting B. On giving 0 to B, you are getting B, and giving 1 to B, you are getting A. I will include an additional column here of output, and will write output of capital A in front of it, and will write the output of state B in front of it. So this is the way by which we can draw out the Moore machine and draw out its transition table. Now, what is Mealy machine? So Mealy machine and Moore machine are somewhat equivalent, but the method of their construction is slightly different. This Mealy machine is also can be defined by using those same 6 tuples, that is q, sigma, del, delta, lambda, q naught. And the meaning of those tuples are also same here. The only difference here is of lambda, that is output function. Now, what is output function here? Here you can see, as I have written here, that output alphabet is associated with a transition, because here the output alphabet is associated with transition. That is why I have written here as q cross sigma maps to delta, because whatever transition, what is the criteria of making a transition? That on what state you are presently at and what input alphabet you are getting, that is q cross sigma. So the deciding parameter for output will be q cross sigma. But in last machine, that is Moore machine, the deciding parameter for output was q only. That means whatever state there is, we will decide our output alphabet according to that only. But here what will happen? We will decide our output alphabet with respect to transitions. Okay, so this is the only difference among these two machines, that is Mealy machine and Moore machine. The only different thing here is output function. In Moore machine, it is q maps to delta. In Mealy machine, it is q cross sigma maps to delta. The construction of this machine, or this example of this machine, is shown here. Here you can see that output alphabet is written here along with the transition. Whatever input alphabet, suppose I have given 0 to A, I am reaching back to A only, but output is not written here with state anymore. In Moore machine, I was writing my output alphabet here, but now I am writing my output alphabet with the transition only. By a slash sign, I will write its output with this transition. At every transition, you can see there are some output written over here. And in transition table, you can see that 2 additional rows are columns are included for output with every transition. Suppose on giving 0 to A, I am reaching to state A, and at the same time I will write its output also. On giving 0 to B, I am reaching to state B, and at the same time I will write its output beside it. So this is the method of making Mealy machine and Moore machine, but there is no difference in power of these machines. If you say that for some languages, for some question, or for some task, we can make Moore machine and we cannot make Mealy machine, no, there is nothing like that. For every task for which a Moore machine can be prepared, Mealy machine can also be prepared for that same task. And for every task for which Mealy machine can be prepared, Moore machine can also be prepared for that same task. The only difference is in the method of their construction. In the former one, we were using the output alphabet with states, and in this latter one, that is Mealy machine, the output are associated with the transition. So that is all about finite state machine with output, in which we have studied about Mealy machine and Moore machine. Thank you so much.